So good morning everyone and welcome to this lecture. We are
Sir, you are not audible, sir.
check your speaker. I can't say anything. Beta, you can see me, you can hear me? Yes or no?
We can hear you.
You need to check your speaker, beta.
It's clear, sir.
Got this? Okay. Chalo. So what we were doing, we were dealing with interference, and I think we had seen what happens in interference. We had seen the resultant intensity. Remember this formula for resultant intensity. Intensity for identical waves we had seen for different we had seen what do you mean by constructive interference, and we had also seen what do you mean by destructive interference. It depends on the phase difference or the part difference. You must remember the phase difference for constructive interference. It is there 2n pi, and the part difference is n lambda. For destructive interference, the phase difference is 2n minus 1 pi. We call it odd multiples of pi. And in case of part difference, it is odd multiples of lambda by 2. This is the prime important thing in this chapter. How do we get constructive thing and how do we get destructive thing? Having said that, now is the time that we are going to move into the main point of this chapter, which everyone thinks that this chapter is all about. What is that point? Huh? Whenever we think about wave optics, the first thing that comes to our mind is known as, that is the heading for the class, YDSE. What do you mean by YDSE? Anyone? It is known as Young's double slit experiment. Young's double slit experiment, YDSE. So that is the heading, Young's double slit experiment. Now, as soon as we understand what is a Young's double slit experiment, the name of the heading suggests what is Young's double slit experiment. So what is going to happen? We have seen interference. So interference is going to happen. Constructive and destructive interference is going to happen, to be very precise, and it has got a double slit. So we have this arrangement which is known as the arrangement for Young's double slit experiment. I think you are going to do the same experiment in your school. This is known as the Young's double slit experiment, and it looks like this. You may not have to draw this, you just need to understand how it looks like. So this is how we have a Young's double slit experiment. So basically, for a Young double slit experiment, our entire focus or our entire aim is to make or is to superpose two waves or two wave fronts coming from coherent sources. So the first thing, and we want to make them interfere at some point. So where are we going to make them interfere? We are going to make them interfere on this screen. Do you see this screen? We are going to make them interfere on this screen. For that, we need two coherent sources. Do you see the coherent sources here? Yes or no? Do you see the coherent sources here? Yes or no?
Yes, sir.
Okay. Just keep on telling me so that I can move on. Where are the coherent sources here? What are the two coherent sources that you see? Those two coherent sources are this
S1 and S2.
this source S1 and S2. And how I produce this? Remember, these are two coherent sources of light which can only be produced by a single coherent source, a single source, and that single source, I call it the mother source. The mother source is here. This is the mother wavefront, if you want to call it. This is the mother wavefront, and from this mother wavefront, I have created two daughter wavefronts, two coherent sources. can be created only from a single source of light. Now, how I have done this to create coherent sources? There are two ways to create coherent sources. One is by the division of wavefront. The other one is by the division of amplitude. Which process have I used here? Division of wavefront or division of amplitude?
Wavefront, sir.
Division of wavefront. That is, you don't have to draw this diagram. This is just for you to see what is going to happen. You don't need this diagram. Just need to understand this. Don't worry. Don't need this diagram. Don't waste your time in drawing the diagram. Just understand what is happening. So I have two coherent sources produced from a single source by division of wavefront, and then I'm making the waves or wavefronts coming from these two sources to interfere. These are the wavefronts that you can see. Ting, 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 ting. These are the wavefronts of the first source. If I call this green, ting, 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 ting. These are the wavefronts coming from the second source, and they are going to interfere on the screen. At some point on the screen, you are going to have constructive interference. At other points on the screen, you are going to have destructive interference. Do we understand this? That is the entire purpose of showing you these diagram, and this is how, if I show you a three-dimensional view, this is how the pattern will look like. This is again from a side view, so that you understand that was the side view. This is sort of the front view, whatever you imagine it. This is my mother source, and these are the two daughters that I've created, S1 and S2, division of wavefront. These daughters, they will throw their own wavefronts, and those wavefronts are going to, or those waves are going to interfere on this screen over here. And what do you see here are some dark patches. All these are dark patches. All these are dark patches. So you see some dark patches and you see some light patches. Do we see this? These dark patches and these light patches are happening because of interference. These are dark, these are bright. Why are these dark patches or these dark bands? We call them fringes. These are the dark fringes and these are the bright fringes. Why we have dark and bright fringe? What is creating dark fringe and what is creating bright fringe? A dark fringe, darkness, intensity minimum. Intensity is minimum. And why is the intensity minimum? Because here what is happening? Huh? Here destructive interference is happening. And then we have the bright fringe, where you have maximum intensity. And why there is
Constructive.
Yes, it's because of the constructive interference. You don't have to draw this diagram. This is just for you to understand that what is happening. One parent source, one mother source, two daughter sources, wavefronts interfering on the screen, bright fringes, dark fringes, constructive, minimum intensity, destructive, maximum intensity. I hope everyone understand what's happening here. Yes or no?
Yes, sir.
Okay. I am going to show you one more snapshot, and probably again you don't need to draw it. This is just for your understanding and nothing else. There's no point of drawing this because it does not make any sense. I will tell you what to draw. This is just for you to understand the concept and nothing else. So this is the diagram that I want to show you. See, mother wavefront, two daughters, each daughter producing its own wavefront, and they are interfering. As you can see, at some points, crest of one falls on the crest of one. We have maximum intensity, or the trough of one falls on the trough of the other. So we have maximum, 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 maximum. And at points in between, you will have the crest of one falling on the trough of the other, and you have minimum, 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 minimum. Don't have to draw this. This is just for you to make some sense out of it, that what is happening. I've showed you in various possible ways, but the way that we are going to use for exams and for for our understanding to do problems would be a simple diagram like this, and this is a diagram that probably you should draw to understand it. Again, the same diagram that I've shown to you, different perspective, though I'm seeing it from the side view, same thing. I'm not concerned about right now where is this source, or we have got one parent source and then I have the two daughter sources. Now all the question that are going to come will have these three terms. The first of these terms is D, small d, distance between the two daughters, the distance between the two slits, Young's double slit, two slits. Then we have this capital D. Capital D is the distance of this cardboard or this coherent sources from your screen. Small d, distance between the slits, capital D, distance between the coherent sources and your screen. What is going to happen? Again, I have shown you interference is going to happen at some points. You are going to see brightness. These yellow points are brightness, 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 brightness. The central region is always a bright fringe, which is known as central bright fringe or central maxima. Above central maxima, you have the first bright fringe, second bright, third bright, and so on. Below the central maxima, first bright, second bright, third bright, and so on. These are happening because of your constructive interference. In between those brights, we have darkness. We have darkness, 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 darkness. Oops. Darkness, 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 darkness. We have central bright fringe. On both sides of central bright fringe, we have dark fringe. First dark, second dark, third dark. Why this darkness coming? This darkness is coming because of the destructive interference. Again, you don't have to draw this diagram particularly, but this is just to give you a two-dimensional view of what is happening here. Okay. So what are the things that you must remember at this point? Let me just tell you some things that you must remember, and I'll give you 2 minutes to note this down. If you want to note it down, please note it down. Then I'll give you some important points that you must remember, because all of these points can come as potential question in your examination also. Note this down, and then I'll give you some important notes. Don't have to draw everything very thing. You can just write dark, bright, and that is it. It is all symbolic for your understanding. Give you 2 minutes. When you are done, please let me know. Please let me know once you are done, beta.
Completed, sir.
Everyone done, beta? The other class?
Yes, sir.
Okay. Now, please note down these important points that I'm going to give you, because one of these points would come as a question, some important points that you must remember at this stage. Now, some of these points, you can understand it right away. Some of these points, in the next class, you would be able to understand, so don't worry. Remember, energy is conserved in interference. Energy is conserved. We might think that there could be a question that a single source is creating two sources. What about energy conservation? That two sources are creating wavefront. At some point, you have destructive interference. Intensity is zero. Energy is also zero. How is energy conserved? Energy is conserved. Basically, what is happening is whatever total energy you have, it is getting redistributed. Energy is getting redistributed. What do you mean by redistributed? In darker regions, destructive interference, you have very less energy falling on that point. But where you have constructive interference, we have more than double, 4 times the energy that is falling on it. Therefore, basically, it is compensating for that energy which is not falling in the darker region. So energy gets redistributed. So interference is just an example of energy getting redistributed. Do we understand this? Yes or no? Then you must understand that if one of the slits is closed, and this just come as question in one of the JEE, if one of the slits has closed or you slit is closed, you cover one of those slits, then what will happen? Do we see any interference pattern? Do we see any interference?
No, sir.
No interference. No interference, that means no interference. You will see no interference because for interference you will need two coherent sources. I hope everyone is able to understand this. Some things, as I said, are very clear. You understand them straight away. Some things we might be able to understand in the next class. Central fringe is bright always. Central fringe is always bright. If we don't do anything else, central fringe will always be bright. Fringe pattern due to a slit. Remember, slit is a opening like this. So it's a double slit experiment. So it's a slit. Fringe width due to slit is brighter than a point. So we don't make points hole. We don't make pinholes. We make slits. If slit widths are equal exactly, slit widths are actually equal, then we will have dark fringes, completely dark. So if you can make both the widths of the slit, the size of the slit same, exactly same, your dark fringes will be completely dark. Your bright fringes will be completely bright. Do we understand this?
Yes, sir.
Now, this experiment can only be happening with a monochromatic light. Monochromatic light means A light which only has one color. Do we understand this?
Yes, sir.
If one slit is red, the other slit is blue, will you see any interference pattern?
No, sir.
No interference. So these are what we are writing are important points, as I can say, as I can tell you. Some points we can understand it right now. Some points we might understand it in days to come, maybe in the next class. Did I tell you about non-coherent sources?
Yes, sir.
Did I tell you the intensity of non? Okay, I told you that. Okay, I just remembered. I was just going through that. I remember this or not. Okay, if one slate is red, other slate is blue, no interference would be observed. What happens if I illuminate it by white light? White light consists of 7 different colors. What will happen?
No interference.
If white light is used, if white light is used, then we'll have number 1. Remember this. These will come as questions in your exam. Central fringe will be white. And I told you some things we can understand now, some things we may understand later on. Lambda for violet is less than lambda for red. We understand this? We remember this? Yes or no?
Yes.
Lambda for violet is less than lambda for red. Therefore, the fringe next to central fringe would be violet. So basically, which fringe will come depends on its lambda. And we will see how it limits on lambda. Fringe next to central will be violet. Fringe, oops, wrong color. Fringe farthest from the center would be
Red.
red. Fringe farthest from the center would be red. Now there is something that we call as fringe width. I will show it to you. What is the fringe width in this diagram, and we will also do the formula for this. What will you mean by fringe width? The diagram is right there, and you can see fringe width, and you can see something very simple. Fringe width. What do you understand by fringe width? Do you look at this diagram and tell me what is fringe width? Fringe width. Sorry, what do you mean by fringe width? Anyone? Can you show it from the diagram? Anyone?
Capital D.
This is known as your fringe width, beta. You can also call it this way. It is the distance between two consecutive dark fringes or two consecutive bright fringes. Beta, fringe width, beta, fringe width, beta. This fringe width is same for all the dark and all the bright fringes. This is one more point that you can write right now. I would have in any ways given it when we had discussed fringe width, but Since we have seen the diagram, we can understand what is fringe width. So fringe width is same. I hope you have seen what is fringe width. Fringe width is same for all dark and bright fringes. So I'll give you 2 minutes to note everything down. Once you're done, please let me know. Each and sorry, one more point is left. I will give you that point also. One more point is left. Now, sometimes you might have not two slits as coherent sources, but I have seen some questions in JEE. When I say JEE, I mean JEE Advanced, where they create coherent sources with a concept known as Lloyd's mirror, where you have one source of light, the original source of light, and then you have one image created by a mirror for that source of light. So in that case, what happens is you have two coherent sources, one of the object and the other is reflected image. In that case, because of the image, because of light getting reflected, when light gets reflected, it undergoes a phase change of 180 degrees. Do we know this? Yes or no?
No, sir.
It's not very difficult. Now you know it. When light gets reflected, it will undergo a phase change of 180 degrees. That means a crest. Do you know a crest? A crest will be reflected at a trough. A trough will be reflected at a crest. So you can write this. When wave gets reflected by a denser medium, we will do these things in your wave wala chapter. Don't worry. Right now, just note it. It will undergo a phase change of pi. Maximum on the positive side, crest becomes minimum. Maximum on the positive side, which is known as a crest, becomes maximum on the minimum side, which is known as trough. So this point that I'm going to say is concerning the reflection of this source. If two coherent sources are produced by a source and its reflected image, in that case, what will happen? Your central fringe would be dark instead of bright, because crest becomes trough and trough becomes crest. I'll give you 1 minute to note this down. Once you're done, please let me know. Most of the points that you are supposed to know are right there in front of your screens. Apart from this, whatever is left are a couple of formulae, and we are going to do this in your Everyone has done this?
Completed, sir.
Okay. So that is about The experiment, what is the experiment, how it is done, one source, two source, interference, that's it. Now we'll have to understand some things. The first thing that we need to understand is where are the dark fringes going to be and where are the bright fringes going to be. We know that the central fringe would be bright, but once we know the central fringe, how do we find out where the other fringes are? And that is the entire exercise that is going to happen. So the next thing would be Young's double slit experiment. And how do you derive the relation between where the fringes are and where the dark ones are and where the light ones are? That is the entire exercise of this particular topic. Where are the dark fringes and where are the bright fringes? Now this diagram is the essence of this entire chapter. So this diagram you will have to draw with utmost sincerity. Now what are the important points in this diagram? Please look at this. These are the two sources, S1 and S2. We see this hopefully. These are created from a single source. S1 and S2 are the two sources. Then the next thing that you have to understand is D. Small d is the distance between the two sources. Capital D is the distance between the source and the screen that is put here. Everyone understands this? Now, this O that you see is the middle point of the middle point between the two sources. Now, what is going to happen is we need to locate where are your bright fringes and where are your dark fringes. I have drawn this point C. At this point C, we are always going to have the bright fringe, which is known as the central bright fringe. We have covered this, yes or no? So what I need to do is, what we are going to do is, we are going to take a random point P. We are going to take a random point P whose distance from the center C or center O, depending on how you are seeing it, is X, or they have written it as Xn, we'll just call it as X. Whose distance, or let me not call it as X because X would be a wrong way to write it. Let me call it as Y. Y. Because it is along Y axis, so let me call it as Y. So the distance of point P from C is Y. Now what we have to find out is what is going to happen at Y. Whether it would be a constructive interference or whether it would be a destructive interference. So far, so good. Do we understand this? So far, so good. We understand this. We are going to take interference at point P. Now, two waves will be interfering.
Yes, sir.
Two waves will be interfering at point B. The first one is the pink one coming like this from source S1. The second one is the blue one coming from the source like this. So these are the two waves that are going to interfere. And then we will have to find out what is going to happen, whether we are going to get dark fringe or whether we are going to get bright fringe at point P. That is our entire exercise here. Do we understand this?
Yes, sir.
Okay. Have you drawn this much diagram? Okay. So what I'll do is I will take this off and I take you to the next part of the diagram that you must understand. Now, what I have done here is you can see these two angles. This angle is theta and this angle. Both the angles are same. These are same because this distance D is very, very large. So you can say that both of these angles are going to be same. Okay. How I have got this angle to be same? Because if I just call them, this is your first angle and this is your second angle. Both angles are same. Angle 1 is equal to angle 2 because this distance D is very, very, very large compared to small d. Can you remember this, beta?
Yes, sir.
Just remember this. These two angles are actually not same. We are taking it same because capital D, the screen is very far compared to the distance between the slits. Okay. Then what I have done here, my dear friends, I will take those two angles off. I have drawn a perpendicular, this SL or S1L is perpendicular to H2L or H2P. I have drawn a perpendicular from S1 onto the line of S2P. These are the important points that you must remember. I'll give you 2 minutes to note down this point. I've highlighted what you have to remember. If you can remember these things, well, congratulations, you are done with your Young's double slit experiment. I'll give you 2 minutes. Note them down carefully. This is the only diagram that we have to do in the entire chapter. And this entire diagram, this one diagram, is going to solve all the questions.
Completed, sir.
Other class, we are done, beta. Please let me know so that I can move forward in life. Life has to move on. The only thing good about this life is that it moves on. So let me know when if we can move on in today's class. Shall we or shall not we? I guess there are more students in the class and everyone is noting it down. Don't worry. This is the most
Completed,
important.
sir.
Your class is done, beta. What
Done.
about my class? I'm more concerned. I'm equally concerned, not more. I'm equally concerned with both the classes. Both of us, this is democracy. So both of us should be on the same page. Done, everyone? Shall I move ahead?
Yes.
Okay. Now remember, remember what I said is what is our purpose. The purpose of this entire discussion is to find out what is going to happen at P. Whether we will have a dark fringe or whether we will have a bright fringe. That is my entire objective of what we are going to do. Now, looking at the diagram, what you are going to find out is, and if I just take you back to since we have a time machine, I can go back. Two waves are going to interfere, right? Two waves are going to interfere at point P. Now, we have done a question like this. Do we remember this question? Yes or no?
Yes, sir.
Here also we had done a similar thing, and that is why I did this question actually. We had two waves the pink wave coming from S1, dhar, 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 and we had the green wave coming from S2, and they were interfering at the point A. Yes or no?
Yes, sir.
We had found out the path difference between the two. Yes or no?
Yes, sir.
That is what exactly what we are going to do now in this case. The only thing is the diagram looks a bit different, but it's the same thing. Again, take you back to the diagram that I drawn. Which one? Which one? The essence of this. So again, there are two waves that are going to interfere at point P. The one is the pink one, darla, darla, darla. It is going like this, darla, darla, darla. Then we have the blue one, darla, darla. We need to interfere these two waves. To make them interfere, we must know, and what is going to happen, we must know the path difference between the two waves. The diagram is right in front of your eyes. Tell me what is the path difference between the two waves. They are not traveling the same path. Yes. What is the path difference between the two waves?
S2P minus S1P.
That is exactly correct. It is S2P minus S1P. That's all. That's all that we need to understand in this Young's double slit experiment, that the path difference between the two waves, and I shall write here, the path difference between the two waves is S2P minus S1P. Do we understand this? Yes or no?
Yes.
Now, if we understand this, we just have to find out the value of S2P minus S1P. We just have to find out the values of S2P minus S1P. And how are we going to do that? We are going to do it by approximation. We are going to do it by approximation. Let me try to make sense. So here I have the 2 points, S1 and S2. And here I have this screen, which is at a distance capital D. Now remember, the distance between the 2 points D is very, very small compared to this capital D. Do we understand this? Now I want the interference, and I'm trying to draw a rough diagram here. This point was C. You don't have to draw it. You can only do it in the drawing that you have done. So basically, there is one line S1P and there is one line S2P. I have to find S1P minus S2P minus S1P. What do I do is I drop a perpendicular and I call this point as L. Now, remember, if my D is very, very small compared to this D is very far, capital D is very far, then I can write, my dear friends, S1P is almost equal to LP. Do we understand this?
Yes.
That only happens when D is very, very far off. Yes or no?
Yes, sir.
That's it. If we understand this, then we also understand that my path difference delta X, which is S2P minus S1P, now becomes simply equal to S2L. How many of us understand this? This is not actually equal, this is almost equal. How many of us understand this? Yes or no? Please raise your hands.
Yes.
We understand this? Once we understand this, done. That is the entire thing. So basically what I need to do is I just need to find out this distance, and this is the path difference, delta X. Now again, the same assumption I am making. The same assumption I am making. The assumption is pretty simple, and the assumption is this D is very large compared to this. D is very large, capital D is very large compared to small d. Now, if I call this angle as theta, now this is the right angle triangle. What is the right angle triangle? This pink thing is the right angle triangle. Yes or no, my dear friends?
Yes.
From here, you know the value of D, which is the hypotenuse. D is the hypotenuse. And your delta x is your perpendicular. You can find out delta x in terms of D and theta. Can you tell me what is delta x in terms of D and theta? Huh? It will be equal to D sine theta. Do we understand this?
Yes, sir.
That's it. That is your actual answer. This answer only has one assumption, and that assumption is D is very far, capital D is very far compared to small d. Do we understand this? Yes or no? No or yes?
Yes.
Now, this is the part difference. Now, let me go ahead and just let me finish this. Everyone has noted this down?
Yes, sir.
Let me just go ahead and do some more things. And I would require your help. Now, let me just have a look at this delta t. Okay. Now, I want, let us say, constructive interference. I want constructive interference at P or any point. For constructive interference, what should be the value of delta x? I'm asking you. For constructive interference, what should be the value of delta x?
N delta.
Ah?
N
delta?
lambda.
And lambda. Yes or no, my dear friends?
Yes, sir.
Now, delta x, look at the top on the right side. This one, delta x is, so your d sine theta should be equal to n lambda. This becomes your condition for constructive interference. Do we understand this? Yes or no?
Yes, sir.
Let me now find out the condition for destructive interference. For destructive interference, this delta x should be equal to 2n minus 1 lambda by 2, na?
Yes, sir.
From 1. So your condition for destructive interference will become d sine theta is equal to 2n minus 1 lambda by 2. Do we understand up till this point?
Yes, sir.
Well, then we will wind up the class here. Now remember, now I'm doing it here purposely because I want you to understand that this part difference delta x is actually equal to d sine theta. There is more to this derivation. Again, I have only taken one assumption up till now, and this is this d is small, very small compared to capital D. Again, based on this assumption, I am going to further simplify this formula, but you must remember this original formula because there could be a question that comes in the JEE. When I say JEE, I mean JEE Main or Advanced, that could only be solved with this formula. So I'll do that question as well so that you understand what's the difference between this formula and the formula that eventually comes. There's somewhat difference between them. So I will carry on with this derivation. The reason that I had to do this derivation was because it is required. If it was not required, I did not derive you the formula of lenses. I did not derive you the formula of mirrors. I did not derive you that formula of refraction by a curved surface. It was not needed. This is needed, and that is why it is done. So we only do things that are needed. Else we don't do it because that is of no use. So that is why we are doing this in so much of detailed analysis, because it is required. Okay, because there could be a question that is going to come from this, and if this question comes, you have to do it. And the difficult questions last year in JEE, when I say JEE, I mean JEE Advanced. Last year in JEE, they had ray optics. So it's very, very likely, and please write it and remember when I said this, it's very, very likely that this year you will have questions from wave optics. Are you getting my point? And if the question
Yes, sir.
comes from wave optics, it will come from this. That is why we are doing it in so much of detail. So we will continue on with this detailed discussion in the next class. Try to wind it up by then. Take care. Have a nice day. God bless you all. Bye-bye.
Bye, sir.